Right, let's just see. That should be pushing a signal, and it is indeed pushing a signal. Right, and let me just get to that point, and somewhere I have one of these. Let's just see if that one works. Yeah, okay, right. So I'm going to ask you to do something. It's just a little bit of physical movement. Today is a very holistic day. We're covering a lot of territory, and I think a bit of physical movement. We haven't really been outside. There's a little bit of sheltered outside out there to give you a little bit of weather. And what has been the weather today? Rain. But it's been kind of like that kind of unambitious rain. I mean, it's not really trying, is it? So we're going to try. So what I want you to do is I want you to stand up. That's the first thing, which is going to be a shock to a lot of you. Okay, but we're good, okay? When you stand up, now, I'm going to ask you to do a sequence of movement. What we're going to do is we're going to evoke a rainstorm. But one of the things that I want you to do, I want you to, at one point, to click your fingers. If you don't know how to click your fingers, just tap them together or in your palm, okay? Just that kind of click. Okay, right, okay, but it begins in silence. And then we hear the storm, just like this. The storm's coming. Oh, there's raindrops. You hear the raindrops falling down. Oh man, this is a big one. I think the storm is just beginning to pass. Okay, sit. Nice and wet. Right, you've got an hour to dry off now. Hopefully I've woken you up. If not, then we can do it again, but, you know. Right, okay, so what I'm going to talk about is not the rain. I'm trying to think if there's any connection to rain in my talk whatsoever. I'm sure I will make one in the next hour, okay? As an additional disclaimer, all of the photographs, with the exception of one, and you are invited to guess which one it is, all of the photographs are taken by me, so I own the copyright. There was no LLM involved, unless you regard me as an LLM. Okay, I leave that to your own personal discretion. Right, so my name is Kevlin Henney. I'm in a bunch of places online. You can find me. My parents were generous enough to give me an internet unique name before the internet existed. Amazing foresight. What we're going to do, does this look like your code base? Yeah, it does, doesn't it? Yeah. So this is one of the things we want to talk about, because I want to talk about reclaiming a particular idea, an idea of refactoring. Refactoring is there's a lot of misunderstandings about what this is. Some of them are mischaracterizations, some of them are oversimplifications for many people, and this is what leads to the title of this talk. Refactoring is not just clickbait. For many people, refactoring is a shortcut menu, which they're aware of, but they don't really explore. We'll come back to going a bit further with that. For other people, refactoring is, wholesale redesign. For others, it is related to deficiencies in ourselves or in our development process. At one level, these are all bound together. What I would like to do is try and highlight the idea in which refactoring is a normal, standard, everyday activity. Whether we name it or not, that name has not always existed. Many of us were not aware of it until a particular point. It's a standard activity, but it's also, and it's not just about messy things, although certainly it deals with that. It is about the way that things change and the fact that we are constantly surprised by change every single time, even though that is the one normal guarantee that you have. Things will change. Oh my goodness, a surprise, something changed. But you knew that. Yeah, you're right, I did. Come Monday, oh my goodness, something changed. Surprise. You can do this every day, every hour. Every organization, every human being is like this. We have a very difficult relationship with change. Refactoring tries to be part of that in the world of software, but it's not just about the software, it's about us. So let's start off with a thought here. I'm going to start off with a quote from Maya Manny Lehman. This quote is taken from a 1980 paper, which is it's a real classic. I went back to it a few years ago, and I was surprised at how well it had aged and how many ideas are still in there waiting to be mined and brought into the 21st century. And although I've said this is 1980, actually this is a culmination of layman's thinking throughout the 1970s. So we're dealing with 1970s ideas here, just in case you were kind of afraid that I might present you with any new ideas. There are no new ideas in this talk whatsoever, okay? As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. I find this sentence absolutely fascinating because I've come back to it over the years, and each time I come back to it, I see something different. Most recently, the last couple of years, there's an observation about the word maintain, which I'm going to emphasize. But first of all, laymen at this point did not have the vocabulary for describing long-term development and the effects of long-term maintenance that we have now. We have a far richer vocabulary. The word legacy did not exist. Technical debt certainly did not exist as a metaphor. And back then, the 70s, people generally regarded the problems that you might have with development that arise from the things that you did in the past as somehow anomalous. It's just like a little blip. It just designed it right. They regarded it as a problem to be fixed rather than this is the nature of the thing that we are building, because this is the nature of us. And the idea that refactoring, as we're going to see, is actually an idea sometimes about discovering your design and reshaping things in response. So you don't really know something until you've truly had the chance to put it out there, mess about with it, see how it responds, but also the world around it changes. But there's an interesting thing here that is inherent. And he's saying, reflecting deteriorating structure. This is unconditional. In other words, we are saying, even if you do your best job, you will still have deteriorating structure. The question is not whether you have deteriorating structure, but to the degree that it deteriorates. Okay? Obviously, if you set out to do a really bad job, then the deterioration, you just fall off a cliff. So this is not a justification for nothing matters, let's be nihilistic. No, this is just an observation. In an ideal universe, if we did the perfect thing, would this all work out? Well, no, it wouldn't. And let's understand, you are doing the best job you can. You are focused. You are focused on that piece of code. You are focused on introducing a change. And maybe that change is a bug fix. Maybe that change is a new feature. Maybe that change is an opportunistic improvement to something because now you've learned something, you recognize something, go, I know this. There's a better way of doing it. I don't care what it is, but you're affecting change, and you are focused. Now, here's the paradox of human existence. If you are focused on something, then by definition, you're ignoring everything else, because that's the definition of focus. To be focused is to ignore everything else. If somebody says, you need to be focused on everything, then you are not. The whole point about focus is you are taking your attention and you are concentrating it, which means you are withdrawing it from other things. You don't know what's going on here. I mean, this is actually literally how we see. There's a little bit right in the center of your eye, the fovea. You've got really good high-res definition, okay? Really good vision. And all the rest of the stuff that happens in your eye, it's low-res garbage. Most of it's black and white. And you know that this is the case because if you want to see something in detail, you have to move your eyes towards it. The amount you can actually focus on is tiny. Most of the rest is ignored and conjectured and filled in by the brain. And that's exactly what happens with your code, unless you are dealing with a system whose whole size is 10 lines. And honestly, it could be smaller. We've had problems with 10 lines of code before. Unless that is the whole of your system, you are ignoring everything. And you may be ignoring something that is now contradicted by your change. You may be ignoring something that is no longer necessary. It's now dead code. It's now contradictory code. It's like, oh, we've introduced an inconsistency. We've now got two stuff. I don't care what it is. The more of this you change and the more focus you have, no matter what your brilliance, the chances are that there's something else that should be done. And maybe we don't recognize it. Maybe we recognize it individually tomorrow, or maybe your colleague recognizes it in 6 months' time. But what we're saying is it's intrinsic to the process of change and focus that you will cause deterioration, even as you are causing improvement. We just heard about this whole idea of like, how can these two statements be true? Synthesis, yeah? It's all connected. But there's another thing here. Unless work is done to maintain it. He's using the word maintenance. Now this is fascinating to me. Maintenance here is actually being used in a way that is perhaps more appropriate and more correct with respect to the real world. We often use maintenance in software to mean bug fixing. We're saying, oh no, it's become broken. No, it has not become broken. It has always been broken from the moment that it was released. That bug is not to do with the natural wear and tear of the world. It's not to do with the fact, in the real world, maintenance is to do with you use something and it wears out. Yeah, it's just like, oh yeah, the washing machine, it's kind of wearing out. We need to change the belt. Yeah, it's sounding a little bit rattly. You don't get that with code. You don't say, oh yeah, we've got the code, and oh, I've opened this file so many times, the curly brackets are falling off. Or hey, did you look at the binary? Yeah, some of the ones are decaying into zeros. Not a thing. We don't maintain it in that sense. We've got a euphemism for, let's just get rid of the euphemisms. Bug fixing, let's change the word bug, it's a defect. Let's use the language, it's a defect. Yeah, by the way, if you were looking for another word for hallucination, referring back to this morning, defect is a really good one. It's defective, literally. We have a defect. In the real world, when we have defects in physical products, that normally leads to product recall, okay? Fortunately, software is a little softer. So we have defects. We're not maintaining them. We are eradicating them. We are fixing them. Maintenance is about saying, this has conceptual design integrity. This has a particular quality. We must put extra work in to maintain it, to maintain that quality. That's the thing that we want. Now, maintenance in this sense is a metaphor. Now, I like definitions, and I'm a bit of a word nerd, so I've got I have a whole bunch of dictionaries, physical. I even still have DVDs with dictionaries on them. We only have one optical drive in the house, so every time I install a new machine, it's just like, where is the optical drive? And I plug this thing in and install a dictionary, like the Oxford English Dictionary, which is almost entirely useless as a usage dictionary. But it's great if you want a history of the definitions. It's a good etymology dictionary. But let's look at metaphor. A metaphor is a way of understanding something. Figure of speech in which a name or descriptive term is transferred to some object different from but analogous to that to which it is properly applicable. It's a mapping. We're going like, I wish to understand this idea, which is complex or abstract, in terms of something that's familiar. It literally comes from the Greek, metaphora, to transfer. Interesting that Julia mentioned the Borges on exactitude in science, because that was the basis for the title of a piece I wrote for O'Reilly Radar a couple of years back on exactitude and technical debt, where I made this observation. It will never map its target perfectly. A metaphor is a conceit. It's not an identity. If something matches something perfectly, then it is the thing. Yeah? It's simple as that. So when people say, we're going to look at technical debt. When people say, oh, technical debt, that's not a good metaphor. No, it's a great metaphor. It's widely understood. It has multiple points of correspondence. And most of its points of contradiction are not egregious. They are not problematic. Yeah? It's a fine metaphor. But if you want to have an exact map for the territory, again, something you limit, then you come to the wrong place. A metaphor, by definition, is George Box-like model wrong. Okay? So, let's have a look at what happens when we distort these things. So diving into the dictionary and discovering the joy of etymology, if you really like the history of a word, this is fantastic. I want to focus on the word legacy here, because this is a word that has undergone a very curious inversion. We adopted it as a metaphor, but it's undergone a very curious inversion. Chiefly computing, designating software or hardware which, although outdated or limiting, is an integral part of a computer system and difficult to replace. Yeah, that sounds familiar. But what is also interesting is the year. Now, I say this is interesting because this is going to divide the room. Because for some of you, so I'm just going to quote Douglas Adams, given that we have Douglas Adams referred to here. Douglas Adams made an observation that anything that existed before you were born or up until the age of 15 is natural in the natural order of things. Anything that is invented between the age of you being 15 and 35 is new and exciting, and you can probably get a career in it. Anything that is invented after you are 35 is unnatural and wrong. Okay? Some of you are already past the 35 limit. By coincidence, 35 years. That's from now back to then. So some of you are going like, this term has always existed. I find nothing strange in this. Those of you a little older are going like, oh my goodness, that's really late. Wow, what did we talk about before then? You know, the thing, we don't have any words. We've got a gap. Naming is hard, but it's really hard when you invert the meaning. By default, when we talk about legacy in English, by default, the word is positive. In software, we've managed to flip it on its head. By default, you know, if you want to say that somebody has left a bad legacy in the world, you have to say they left a bad legacy. If you say just the person has left a legacy, by default, that means good. In software, by default, we have the opposite. Now, there are lots of informal definitions of this, but this is a classic legacy system. It's about 4,000 years old. It looks, you know, we don't know who built it. We don't know why they built it, but twice a year it seems to work. And we're afraid of changing it. And there are many informal definitions that people will use. I've run workshops on legacy code, and there's no right definition, although there is a nice, interesting definition in the Oxford English Dictionary. There's no right definition. And I run, because it turns out that people often end up with different meanings. Sometimes, for one person, they might say, oh, legacy, because it's based on technology that is no longer supported. For another person, it's based on decisions that we no longer know because those people have left the building. These are both valid. Legacy is a broad term. One of my favorite ones that always comes up, inevitably, legacy code is often defined as code that someone else wrote. Yeah, normally at least once per workshop, somebody will put that up. Now, but there's a really interesting one that I came across recently from Angel Sierra. Legacy code is often defined as code that makes more design decisions than the team working on it. I find this fascinating on two levels. One is I have never heard this before, and I've been in this space for a while, about as long as the term legacy has existed. I've never come across this. And two, I absolutely love this, because it is such a good characteristic. Who's in charge here? Is it us, the team, or is it the code base? You're sitting there, and as a team, you're collectively deciding, OK, we're going to do this. The code base is sitting there in the corner going, I have a veto. I have the strongest vote here, and I say no. Yeah, we're agile. The code base is going like, oh, no, you're not. Have you seen the state of me? I think it's such a good way of understanding where the center of gravity of decisions and control lies. And then Angel goes further. Could we define a legacy process as one that makes more decisions on how a team functions than the team itself? It's like, wow, this is good stuff. This is a really compelling way to think about it. But where does this stuff come from? Creation of legacy code, there are many sources. Time renders good decisions into bad decisions. It doesn't mean that they were intrinsically bad. They've just become poor through time. A decision that you took a year ago, there's nothing wrong with it. It doesn't invalidate what you did a year ago. It just tells you that, today is different. And those brilliant decisions that you're taking today, you will have the similar perspective in future. But also, options that you rejected in the past now actually may be suitable. We're very bad at adjusting to this shifting scenery. Sometimes we also invite complexity. Because we can't predict the future, we add loads of complexity in. Sometimes we end up with designs that are at the other end of the scale. They are overly simplistic. Not simple, but simplistic. In other words, they are too simple for what they are trying to do. But there are many sources, and a number of them are to do with human factors. But let's look at one of the most interesting human factors. Given that Michael was talking about LLMs, I feel the need to talk about LLMs. So I tweeted this on Mastodon over a year ago. The practical consequences of using LLMs to generate code is that many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code and have redefined their job role as debugging and fixing such code. I want you to think about that, because I just told you that one of the definitions of legacy code is code written by other people. What have I just done? Have I saved myself time? No, I have no idea how this works, because I didn't write it. And strangely enough, ChatGPT is kind of being a bit vague about the its exact motivation at that point and how much coffee it had had. And the conversations that it had that led up to that. I did a bunch of prompts, and who knows? The point is that there's a lot of people who are experiencing a false acceleration of their productivity, because what they're actually doing is creating stuff that they don't truly necessarily understand, especially if they copy and paste it rather than have it advise and filter into their own thinking. You need to absorb it in your own thinking. So what is interesting is that I made this kind of as a prediction, and I did not expect to be validated so quickly. Within 9 months, GitClear had done this study, coding on Copilot. 2023 data shows downward pressure on code quality based on an analysis of 150 million lines of code. Downward pressure. In other words, code is getting shittier, if you want the technical translation. This is interesting. But how do they characterize it? I thought it was interesting. We find disconcerting trends for maintainability. Code churn, the percentage of lines that are reverted or updated less than 2 weeks after being authored, is projected to double in 2024 compared to its 2021 pre-AI baseline. In other words, people are checking stuff in and they're going like, well, that's crap. Oh, that's wrong. Oh, no, that's not right. In other words, people are becoming busier. People are moving faster, but they're not necessarily moving more effectively. We further find the percentage of added code and copy and pasted code is increasing in proportion of updated, deleted, and moved code. Now, this is really interesting because this is actually one of the ways I tend to characterize the difference between well-factored code and less well-factored code, is what you will find a developer who's working with the code on its own level. They often kind of, oh, here's an idea. This idea is right, but it lives in the wrong place. We're doing the right thing, but it doesn't belong here, so let's move it. Give it a place of its own responsibility. Name that responsibility. Oh, this thing's happening in 2 or 3 different places. Maybe there's a unifying concept that we didn't see the first time round. Oh, there it is. So it's about movement. It's about consolidation. And in other words, we're working with the clay. We're working with the materials as they are, but it's, oh, yes, I can update this. Oh, this is no longer necessary. In other words, there's a real gardening attitude to this. This is exactly how my wife gardens. And it's very, very responsive to the situation. Whereas adding things and copying and pasting and duplicating, this is a less effective style. Now, what is interesting here is that they opened the paper with a kind of a question. Is coding with an LLM, is it like having a senior developer deeply experienced in your code assisting you and you're working alongside them? Or is it like having a short-term contractor who just comes in, does some stuff, and leaves? Yeah, guess what? We know the answer now. In this regard, code generated during 2023 more resembles an itinerant contributor prone to violate the dryness, duplication, don't repeat yourself, of the repos visited. Now, I'm not saying, ooh, LLM's bad. I'm just saying that for the majority of people using them, they are going to find that their code, the effort that they now have to put into their code, now changes, and they're going to be busier than ever. Your jobs are safe. You can go home. For a few people, they will truly understand how this tool works, and they will have a massive advantage. But for most people, their work will either remain the same when they use an LLM, or will get worse, and they will create themselves more work. And how do we characterize such work? We often refer to it unconditionally as technical debt. Now, technical debt is a much more sophisticated metaphor than people are aware of. For example, a lot of people assume technical debt is a bad thing. That's not the meaning at all. Technical debt can be a bad thing. Technical debt is about trade-offs. Yeah? It's about the notion, just like with real debt. I mean, obviously, I'd rather not have any debt. But given a choice, we often use debt strategically. We use debt to achieve things that we cannot otherwise do. My wife and I had a mortgage. That's a debt. What do we get in return? A house. Could we afford a house without a mortgage? No. That's a big benefit. Structured repayments. In other words, it's well understood. In other words, that's the whole point. That was the origin of the debt metaphor. But it also has the other side, is that debt can get out of hand. Debt can be unmanaged. We have negative associations. So the thing is, people have rested on the negative associations rather than looking at it as a conscious decision that we might take over time and then respond to that situation. But let's look at something else. Let's look at a different way of looking at that, because sometimes people talk about technical debt and they say, well, you have a technical debt problem. And I'm not going to contradict them. Well, actually, that's not true. I will contradict them. But, I might do it nicely or I might do it flippantly. But there is a point that they're confusing cause and effect. People are often identifying an effect. And specifically, what they really mean to say, and I want you to at least walk away with this in your vocabulary, they are dealing with unmanaged technical debt. Let us divide this in terms, we had a mortgage, managed. However, I'm not very good with money. No, actually, my wife says I'm very good with money, just in the wrong way. Oh, I see a thing. Maybe I should buy it. Oh, my God. Yeah, I'm so good at that. The paying off bit, not so much. In a structured way. I have a lot of unmanaged, or had a lot of unmanaged debt. Unmanaged. It's the distinction. It's not debt or not. It's not whether you have debt or not. It's whether you're managing it or not. So most people, when they say we've got a technical debt problem, well, that actually means we have an unmanaged technical debt problem. And by using that extra word, you've suddenly started talking about what really matters. And now you realize, wait a minute, that's an effect. What was the cause of it? How did we end up with this stuff? We've confused cause and effect. So I want to talk about the boat for a moment. This boat. I want to talk about, we're going to take that boat out onto the water. And we are going to discover when we are out in the water that there's holes in the boat. And that we are taking on water. And I want to describe to you 2, maybe 3 ways of solving this. 2 of which are known to software developers, and one of which is what everybody else on the planet will do. So I want to tell you what you will do, and then I want to tell you what everybody else on the planet does with this boat, okay? Okay, so default case is there's a lot of programmers that go, oh, the boat's just sinking. Yeah, well, that's like it always is, isn't it? And they will just sink. Yeah, everywhere I've ever worked, it's like this. All coding sucks. This is my experience. I feel utterly disempowered. I've got learned helplessness. I'm just going to sit here and go, told you so, told you, another project, exactly. I will be satisfied but wet as a result. I was right about everything being wrong. Okay, let's be a little more constructive. What we're going to do is we're going to get really good at getting the water out of the boat. Oh, we're going to optimize that. We're going to fix that. You remember I said I ran some legacy code workshops and stuff? I've had, it's nice occasionally I get a follow-up from a company. And one of the ones I got, a couple of companies a few years ago, was like, yeah, this is really working. We came up with a plan, Kevlin, as a result. It's great. We kind of responded to it, and we dealt with all of that. Fantastic. Warms my heart. And then my heart freezes over when another year passes, and they email and say, we've got the same problems again. It turns out the bit they forgot was you've got to learn how to stop the water coming in. It's no good paying off the debt if you keep running. This is me with my credit cards a few years ago. Yeah, sure, I'm paying it off every month. Oh, I'm going to go and buy that. Oh, and that looks good. The point is you've got to learn how not to take on water. I'm in the right country for this, okay? You should know this. That the point is, this is what everybody else will do. It's like, water's coming in, okay, we've got to stop the water coming in. That's the thing. This is the cause of technical neglect. Technical neglect can lead to unmanaged technical debt. Technical neglect is like any form of neglect, whether physical, emotional, medical, or whatever. Neglect, but why is it taken so long for us to recognize this as a concept? Because it's not a thing that we do. It's invisible because it's a thing that we don't do. It's very hard to see a thing that doesn't happen. We're looking for things that happen, okay? And we're really good at that. I'm fixing a bug. I can see that happening. I can see the direct consequence of that. I'm doing it. I'm adding a feature. We are having a meeting. I am looking at pictures of cats on the internet. These are all doing. But neglect is not a doing. It's not a thing. You can't observe it because it's not there. That's why it's so hard to see. So let's get to the point about where we respond. Who's familiar with commit strip? Not enough of you. Go to commitstrip.com and waste a good half a day. So we've got a project manager talking to a developer. So will refactoring the code improve the loading time? Not really. Will it improve security then? Nope. So it's for browser compatibility? Absolutely not. So tell me, why is it always the same story with you guys wanting to refactor everything? I need to know. Because as devs, if we know we've left messy code, we can't stop thinking about it. When we wake up in the morning, at lunchtime, in the evening, when we go home, and when we're trying to go to sleep, it haunts us. Right. We care too much, perhaps. But the point is that you're often problem solving without realizing it. It's not even about messy code. Sometimes you just realize on the way home, there's a better way to do that. And sometimes on the way home, it's an easy thing to fix because, home is actually the room next to wherever you're working. And so then you go back and you fix it. And then before you know it, it's, 2 o'clock in the morning. So the point there is we are learning what we've got to do is understand that we are shaping a system. We are literally creating an architecture in this sense. An architecture is a space where we live. People often focus, when they talk about the architecture metaphor, on structural qualities. These are all true. These are all relevant. This is certainly part of the conversation of software architecture, but something else we need to remember is the whole point of the architecture metaphor is it's a space in which we live and work and play. That's what we do buildings with, or buildings for. So therefore, the same is true in our code. We need to think, what's the quality of life in that? If we're going to talk about sculpture, then there's this wonderful quote from George Pentecost. You can find variations of it on the internet, variously attributed to Abraham Lincoln, Leonardo da Vinci, whoever. But the one that I've been able to find that is legit, real, George Pentecost, the angel in the marble. There is a beautiful angel in that block of marble, and I'm going to find it. All I have to do is to knock off the outside pieces of marble and be very careful not to cut into the angel with my chisel. It's a task of discovery. And you might say, this is really interesting from a software point of view. You know what? It really is interesting from a software point of view, because in software, it doesn't matter. We can chip into that angel because software is soft. Let me change the font so it looks soft. There we go. Software is soft. We have reversibility of time. If you chip off the angel's wing, it's just like, undo. Sorted. We have time travel. How cool is that? Yeah. So, by the way, if you are looking for something more interesting to put on your business card, if you still have such things, then, time traveler is good. Yeah. Next time any member of your family asks, what is it? You have some kind of big family get-together, and they ask, what is it that you actually do? Because, make sure that you don't say, I'm in software or I do computers, because you will be fixing their computer. You say, I'm a traveler across the realms of cyber time. What do you do? They're going to leave you alone, just like don't talk to them. They're a little bit of something not quite right there, whatever the reason. The point here is we have softness. This is the thing. This is one of the things that distinguishes the way we think about design and how we respond to the medium, is that it's very forgiving, hugely forgiving, and yet sometimes we treat it as if it's not. You can't touch that. Why? Because it's made of stone. No, honestly, it's not. It's just text. I've got tests. It's got a formal syntax. I've got refactoring tools. I can shape it, and I've got undo. And I can revert back to earlier versions. This is an immense amount of power that we really don't exploit enough, and it's in the nature of the thing, yet we approach it as if it's not. And we prevent ourselves from making certain classes of change. Now, this leads us to refactoring. Now, this book was one that changed the way that I thought about the stuff. By the time this book came out, in 1999, I was already familiar with the ideas of refactoring. I'd heard the vocabulary. I'd seen the discussions on the C2 wiki. I was familiar with Kent Beck's extreme programming stuff, and the ideas were familiar, but I didn't have a full vocabulary and a structure. And this book gave me that, and there's a lot of really good observations. There's a second edition published more recently, but this is the one that really kind of changed the landscape. And Martin likes definitions as well. Refactoring. Now, let's be clear about what it is and what it isn't. It's not just arbitrary changes to code. It's a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. We're going to come back to what we mean by observable behavior in a moment. But notice it is filled with intention, and it's quite specific. We are not going to change what it apparently does. We're going to change the way that it does it and the way actually we relate to it. And remember, when we talk about cost, always remember that cost is, when we talk about economics, remember that economics is a social science. It's about us. It's not about the nature of the universe. Economics is not actually about physics, even though it seems to, you end up with a lot of physicists employed in it. It's about people. It's ultimately about us. It's how we relate to it and what we are prepared to do. A lot of the work, in fact, the cover, if you look back here, you'll see with contributions by Kent Beck, John Brandt, William Opdyke, and Don Roberts. It's Bill Opdyke. It was his work, really, that set the scene for this. In the late 80s and early 90s, he wrote, this is his PhD thesis, Refactoring Object-Oriented Frameworks, Bill Opdyke, Ralph Johnson, advisor. Those of you who are familiar with design patterns, yeah, it's the same Ralph Johnson, Gamma, Helm, Johnson, Flaccides. And he made the observation, similar observation in terms of language. The refactorings are defined to be behavior preserving. So let's look at an example of behavior. At this point, you're going, oh, it's been a while since lunch. Yeah, don't worry. When I shut up, we're done. There's other stuff. You know, we can eat. We're talking metaphors, right? Don't forget, everything we do in software pretty much is a metaphor. Those things that are on your desktop, well, that's not a desktop for a start. I know what a desktop looks like. And those windows, those aren't windows. Yeah, I mean, sure, you can open them and close them, and you can see a view through them, but have you ever tried to resize a window in the real world? It's surprisingly expensive. Remember, metaphors are not identity. So here, this is a stack. And I can write this one up in, I can create an interface for this, how I want to think about and use a stack. A stack has depth, or it has height, or it has a count. Maybe it has a size. It doesn't have a length. I'm sorry, Python, that just sucks. Length is a horizontal concept. Stacks are not a horizontal concept. Queues are a horizontal concept. They can have a length, but they can't have a height or a depth. Yeah. So that's the whole thing about metaphors. They come with a language. That's the whole idea. That's what you're trying to tap into. And they have a top. All those APIs that use peak, no, that's not the original. The original stack, abstract data type, as written by Barbara Liskov 50 years ago this year. That's the original stack in computer science, or rather, original abstract data type stack. She used top. I'm gonna follow Barbara. Pop. I'm going to say this is void. I don't care. I'm going to basically say I'm going to have a strict pop. It doesn't return as a side effect. It just eliminates the top element, and push allows us to push something onto the top. Now, I've got a number of different ways of implementing this in TypeScript, but what I'm interested in is the fact that I can implement it like this, where I use an underlying array, and what I do is I treat the top as the last element, and therefore all my operations are on the last element. Or I can refactor it. In fact, I can turn the whole thing upside down and invert it and treat it as the 0th element. From the outside, you will not see a difference. We have preserved this. We have preserved the visible behavior. This is a refactoring. The choice between these two approaches to data structure is a refactoring. So we can actually come up with a very simple way of understanding the nature of change based on a right-hand rule. If we start thinking about the qualities of code, we can think about the qualities of code as being functional aspects. In other words, semantics. Operational characteristics. In other words, how it does it in terms of memory usage, performance, all of these things. And then developmental characteristics. Okay? In other words, is it well structured? Is it easy to refactor? You know, do we understand it? Is it well named? What is interesting is the first, so we often confuse character, we are very good at confusing categories in software. Commonly people will lump operational and developmental and call them non-functional. Please don't do this. We're supposed to be responsible adults, except the youngest one who's out there. I'm getting in early with her, yeah. Making sure she's going to use the right vocab. Non-functional is not helpful. What's the default meaning of non-functional in English? Broken, yeah. Yeah, I want you to have that conversation with your clients. What are your non-functional requirements? They'll look at you blankly. Or they'll say, oh, we want it to crash every Friday. Because we don't want it to work on Fridays. That's non-functional. That's a non-functional requirement. No. But it also shows a staggering lack of imagination. What are these requirements? These are functional. What are those? Well, they're not those. Well, what are we going to call them? Not those. Oh, come on. I've got 2 children. The first one's called Stefan. The second one's called not Stefan. No. we gave child number 2 the same love and attention in terms of naming as we gave number 1, Stefan and Yannick. It's just like, no, not Steph. No, don't do that. Don't do this at home and don't do this at work. Let's be precise, because it also turns out we're hiding something. We've thrown 2 things together that are actually quite different. Operational characteristics are things that somebody can experience as the code executes. If I improve the operational characteristics of something, you go, oh yeah, it runs faster. As a user of that code, I experience that improvement. If I fix a bug, I've changed the semantics. If I add new behavior, I've changed the semantics. I can experience that, but developmental is not experienced by the user at the runtime. It's experienced by the developers at development time. If this code is messy or has unmanaged debt, I experience that. Nobody's going to notice that directly outside. So we conflated these things. So we need to separate them out. So if we add features, we move on that axis. What happens to operational characteristics and developmental characteristics? I mean, ideally, when you add a feature, you don't make the code worse, but we've also recognized maybe we do. But we may improve, and we may improve characteristics of performance, but they may get worse. The point is, our goal is the plus on the functionality axis. What happens when we fix a bug? Funnily enough, it looks similar, but it's not. Fixing a bug is not like adding a feature. It's like fulfilling a promise that you somehow failed to give. It's a deficit. Oh, interesting. Defect and deficit are very close in spelling. Because a defect is a deficit in functionality. This code should do this, but actually it does this. That shortfall is a thing that it doesn't do. It's a thing that it should do. It's a deficit. And what we're doing is restoring what should be there as opposed to adding something that is new, genuinely new. Then optimization is interesting because it's a behavior-preserving transformation. And it turns out that when people often use in computer science the term behavior, they don't actually mean behavior. In the real world, behavior includes characteristics we would think of as being operational. If somebody says, oh, wow, you ran fast, or you ran slow, then I'm saying something about your behavior. Whereas in computer scientists say, oh, no, performance is not a thing. That's somebody else. We have a different department for that. That's electrical engineering or software engineering. Now, in computer science, we don't care about performance, except to talk about it. And we go, oh. Oh, some of you got it. Thank you. So the idea there is what we're doing is we are observing that with an optimization, our goal is to improve something in the operational axis. To be fair, we often end up with negatives in other sets. Oh, we're going to use less space, but we're going to take more time. Or we're going to use less time and take more space. But the idea is our goal is along that axis. What happens to the axis of semantics? The functional axis. This is the stuff we can unit test really easily. We say that does not change. There's no virtue to breaking this. In other words, if somebody says, yeah, I optimized the hell out of that code. Yes, but Kevlin, it's really buggy now. Yeah, but those bugs are really fast, right? That's not a virtue we're looking towards. So we've added a constraint. That doesn't change. We move positively in that direction. What happens to the developmental quality? Maybe it simplifies, maybe it gets better, maybe it gets more complex. A piece of code where I add caching is intrinsically more complex than a piece of code that does not have caching. Therefore, there's going to have to be more calories burnt in understanding that. It's not to do with the code quality, it's just developmental complexity has risen. And refactoring is kind of like a chiral image of that. What we're doing there is we're saying, yep, we don't break the functionality, the semantics are stable, but what we do is we improve our experience and developmental interaction with the code. And operational stuff, maybe it gets better, maybe it stays the same, maybe it gets worse. So this is a useful thing. You can actually organize your commits by this. Which axis did I move along? If I moved along all axes simultaneously, then that's probably fairly chaotic. I used to work with a guy, funnily enough, his name was John Smith. I mean, that's kind of an anonymous name. But so were his commit messages. It's just like every commit message from John was, oh, added some code, fixed some bugs. It was like a bit of everything. It was just like, yeah, we moved all over the place. Who knows what the diff of that looked like? So what is the act of refactoring? To restructure software by applying a series of refactorings without changing the observable. Well, that all seems really familiar, except, for years I missed, although I did it, I missed the fact that Martin really made an explicit point about it. A series of. it's not just the verb version of the noun. He's saying it's a journey, that when we talk about refactoring, there's a number of steps, that this is part of, it's a process. It's not merely an action that happens and we're done. It's a process. We are journeying through time. Now, we've got a number of ways. So let's talk about the one that many developers who join software development today are going to come across. And this, again, dates back to Bill Opdyke's stuff. The focus of the thesis is on automating the refactorings in a way that preserves the behavior of a program. Automated refactorings. For a lot of people, that's just what refactoring means, and anything else is not refactoring. Well, we need to broaden that definition, but we also need to understand the potential benefit. And a number of years ago, I put this book together, 97 Things Every Programmer Should Know. You can find various versions of it online. I made sure it had a Creative Commons license. And there's a nice piece by Dan Terhorst North, Code in the Language of the Domain. Now, he's focusing on this idea of using domain language and all the rest of it, but actually it's a nice illustration of a fairly common refactoring. Now, when we look at this, we can actually see, naming's come up a few times today, the names are actually pretty good. Portfolio IDs by trader ID, get trader.getID contains key portfolio.get. All the names, it's portfolio, not portfolio. Yeah? The only abbreviation there is ID, and that's not a programmer abbreviation, that's a real-world abbreviation. People use that in meat space. But this is challenging to understand. We don't understand the intent. It's a lookup of a map within maps. What's the intent of that? Oh, if trader can view portfolio. Right. This is to prevent insider dealing in an investment bank. People are permitted to or not permitted to interact and look at certain portfolios. All of that mechanics is still there, but what we've done is we've bound it up. We've said there's a thing here that wants a name. We've moved that code and given it a name. And so this is kind of, we might say, yeah, these are the automated refactorings. So I made this observation a couple of years back. I'm guessing it was, I think we were at the peak of the pandemic. I had nothing else to do. One of the great things about languages with modern IDE support is thanks to refactoring tools, legacy code is a thing of the past. Unlike with older languages, developers never have to experience long methods, rambling classes, poor identifier names, complex logic, etc. I envy anybody who has entered this industry in the last few years. You don't have to deal with legacy code like us old folks. You just go in there, you open the file, and everything, you can read everything, everything's small methods. You have no idea what it was like, except that you do. Some people didn't wait for me to tweet this before. Oh, but Kevlin, you're wrong. We have terrible legacy problems. Yeah, you have worse legacy problems than when I joined the industry. It's got worse. But one thing we have learnt, it wasn't the tools that were missing. We've had the tools for a long time. And I'm going to make this comment about LLMs. It turns out it wasn't the tools. We've had 20 years of mainstream access to refactoring tools, and code is shittier than ever. It is staggering. There shouldn't be any Java legacy code. That's the language that's benefited the most. About 80% of the things people complain about are solved problems. It wasn't the tools. It's us and the way we relate to the code and whether we feel we have permission, time, comprehension, whether we even know what good looks like. Because it turns out you can't just tell somebody to refactor unless you know what that destination is. And it's just, it turns out there's a bunch of stuff missing, and it wasn't to do with the presence or absence of tools. It was to do with something in us. So I then followed this question with a couple, this observation with a couple of questions. Serious, some general refactoring questions. So, what family of refactorings do you find you use most, whether automated or not? So obviously this is completely unscientific. I go to Twitter at large, see this, and no surprises. For me, I made a prediction before posting this. My prediction was I'm expecting to see people say extract method. In other words, I'm going to take this chunk of code and I'm going to move it somewhere and I'm going to give it a sensible name and rename. And guess what? These were the most popular. We're going to rename that. OK. Of course, there are boundaries to rename. You can't rename everything. It turns out that some things are particularly resistant. Not everything is easily open to change. You put something in an API, good luck changing it later. You release it to other people. You publish the API. Okay? We see some classic examples of this. My favorite one, clonable. If you've worked with Java, you know, that's clonable. If you've worked with .NET, iClonable. If you work with English, clonable. Huh. And you're probably going, yeah, but English, it's got a crazy, you know, English doesn't have a system of spelling. You are wrong. English has about a dozen systems of spelling. That's the problem. It's not the lack of one, it's the fact that it's backed all of the horses and it's put everything in its basket. And you can actually change spelling conventions halfway through a word. Yeah, we just keep people on their toes. It's the ultimate shibboleth. But in this particular case, it turns out this is actually how you spell clonable, not with that extra E. Is this something that we only discovered in the 21st century? No, it's something we discovered before the first major public release of Java. This was a known thing. This tells us we need to respond to information. This bug report was filed in 1996 at version 1.0. Just to confuse you, 1.0 was not the first public release. 1.0.2. Just to keep you on your toes. It's not just English that messes things up, it's software companies as well. And the observation is that clonable is spelled with only one E, clonable. Ask any geneticist, including my wife. Good to have in-house expertise. English specialists such as Henry McGill. Now, this is where it gets funny, because that's not how you spell English, and I had to look this one up. That's not how you spell Gilton either. There is actually a term for this. It's called Muffrey's Law. You may well have experienced this. If you write anything correcting or criticizing the quality of someone else's editing, proofing, spelling, grammar, there will be some kind of editorial error in what you have written. Yeah, it's obviously a play on Murphy's Law, but yeah, this walks straight into that. So there is an interesting thing here. Yeah, this is embarrassing, yes, on two levels, it turns out. Let's fix it before we ship. We can't fix it after, and right now, very little code depends upon this typo. This is an observation about the idea that not everything is equally open to refactoring. It's actually down not to the size of the thing, but the size of the dependency set on the thing. In other words, if lots of people depend on something very trivial, it's no longer trivial. You try changing the spelling of clonable. If Oracle's just sat there and go, we'll just rename that, it will take one developer less than a minute to do. It will take Oracle months, if not years, to recover from. Yeah, same for Microsoft. It turns out, and this again is an important thing, my relationship, oh, that's just a spelling mistake. Death Star picture blowing up, yeah? Yeah, the consequences are huge. And that's actually why some things are harder to move. So the point is that when something's an interface, it has more weight. It's harder to move, it's harder to shift, because everybody depends on it. Don't be distracted. Often people think architecture is about the big things. They're kind of right, but it's the way that things are made big. They are often made big through dependencies, not through their intrinsic qualities, but their extrinsic qualities. This also tells us, by the way, that we can change language. If you go to Wiktionary, it's got clonable, but look at what we've done. Look at what we as a profession have done. Repetition legitimizes. Repetition legitimizes. Repetition legitimizes. This is actually a cognitive bias. If you see something repeated many times, you start to think of it as the default truth, regardless of any other qualities of it. So we have this. Now, it also informs us that we recognize not everything has the same softness. But it tells us we can learn from that. Don't publish interfaces prematurely. You know, it's not just try things out. Be empirical, be experimental. Have soft releases. Modify your code ownership policies to smooth refactoring. Yeah? The silos and boundaries can obfuscate this and make it difficult. This is the other question I asked. What refactorings do you feel are most overlooked or underutilized by you or others in practice? So not all the extract family comes about. Extract class. This is the one that is really visible. Classes become like black holes. They just attract more matter, and they get bigger and bigger. Eventually, you start measuring your classes in terms of megatons, because that's how big they are. You start measuring them in terms of their event horizon radius. You know, you start saying, we don't understand this code. Let's get the people who did the event horizon telescope to understand our code for us. The point there is it just gets heavier and heavier. It's got a strong surface tension, because if I extract a class, it also leads to a new file, which is a new commit, whole new, in other words, it has about, if I keep within the bubble, then I can just add stuff. And obviously, I don't feel bad about it because the other 1,000 additions that came before me all did that as well. I'm just going to add one method. You know, nobody's going to notice one method with well, yeah, my co-author Frank Bushman, we were having this kind of, well, it was an informal conversation, but I guess it was a pissing contest as well a few years ago. And I said, yeah, Frank, I was at a client, and I saw this class, it was 20,000 lines long. Whoa, 20,000 lines. That's actually bigger than some operating systems used to be. 20,000 lines. And Frank looks at me and he says, Kevlin, I'm working with a team where there is a class that has 20,000 methods. Okay, you win and you lose. Inlining things, the reverse of extract. Replacing things. We've got a better way of doing this. We can replace conditional logic with polymorphism or table lookups and things like that. It can become more elegant. So replacement, this is the updating in place kind of thing. Deletion, removal. An observation I made a number of years ago. Decremental development. We're always talking about incremental. Decremental, let's just get rid of some stuff. Yeah, let's reduce the size of stuff. And the overall philosophy articulated by Hans Hofmann, the ability to simplify means to eliminate the unnecessary so the necessary may speak. That's what you're really trying to do. In code, there's always going to be some accidental complexity, some noise, but what you're trying to do is let the core ideas be visible. And you don't always know that in advance. You don't have the knowledge to do that. But over time, certain ideas, you go, oh, this is the most important idea. I want to make it more prominent. Or there's a better way of doing this. Let me show you. So actually, let me show you. We've talked about coding all day, but nobody's really put any code up. So I'm going to put some code up. For those of you who have sensitive, you know, a bit sensitive to code, you know, shield your eyes. But this is not bad. This is the kind of code we might do initially. What we're doing is in Java, we are going to say, you know, give me a collection of strings, and I will return you something you can iterate over that will be those strings in sorted order and unique. I will eliminate duplicates. And this is not necessarily a bad structure. This is the kind of thing we might go at first time. So I'm not going to blame anybody. Remember, you know, we're not always in the best mood. We don't always see the best opportunity. We're just sitting there and go, yeah, okay, I'm going to create a copy of it. I'm going to sort it. Yep, sort is available in Java. And then I need to, oh, okay, I'm not really sure how to do this. Okay, what we're going to do is we suddenly change level of abstraction. We fire up the engines. There's a loop. There's variables. There's stuff happening. We have got to go through this and find the duplicates. So let's remember, now it's sorted, the previous one. Remember the previous one and keep comparing it. And if it is the same, then get rid of one. Brilliant. But I've described it very mechanistically. There is absolutely nothing wrong with this in terms of mechanism. But we kind of, you know, we've really shifted the level that we were talking at. How do we refactor this? The most instinctive one is to extract method. What I'm going to do is I'm literally going to abstract. To abstract is to remove. I'm literally going to pick this idea up and I'm going to give it a name. Remove adjacent duplicates. That's what that loop was doing. That's now much clearer. And this reads as a straight narrative. We create a result that's a copy of the original. We're going to sort it, remove the adjacent duplicates, and return. Oh, this is nice. But this is just movement. This stuff is still there. We haven't really changed the thinking model. We've just moved things around. Nothing wrong with moving furniture around. And you know when you're tidying up, sometimes half the trick is let's move stuff around. Just see what happens. We haven't changed the nature of how it's doing it, just the way we've organized it and how we presented it. We've got far better presentation. But maybe if we were to think about it differently, what I'm going to do is I'm going to take those words, I'm going to stream them, I'm going to sort them, I'm going to uniquify them, look at the distinct, and then I'm going to convert it to a list. Wow, that's a nice flow. I've now turned it into a data flow problem. It was previously a control flow problem, where we've got our hammers and our tools going bang. I'm going to bang this. I'm going to hit this array list, and I'm going to fire up a loop, and I've got all the mechanics going. But actually, now I've just got this really nice flow. I can even optimize something, and it's just like, yeah, I've got rid of an unnecessary creation of collection creation. But sometimes you need to take a step back and realize you've been looking at it wrong. Oh, yeah, there's a thing that is that. We were thinking, we moved from control flow to data flow, But actually, it's not a flow problem. It's a representation problem. The late Fred Brooks, Mythical Man Month, made this observation decades ago. Sometimes the strategic breakthrough will be a new algorithm. Much more often, strategic breakthrough will come from redoing the representation. This is where the heart of the program lies. It's a really interesting one because I see that many of the problems people have, not all, but many of the problems people struggle with when we characterize legacy code and when we look at it, they're lost in control flow. It's the control flow that's got away from them. And actually, sometimes you kind of need to take a step back and go, wait a minute, there's a way of saying this. Not simply a way of narrating it in time, but there's a different way of looking at how we frame it. And that's a radical shift. There's a similar observation in another piece in 97 Things from Burke Hufnagel. I mean, this piece is lovely on 2 levels. One is the title. I mean, this is great advice. If you're ever stuck, put the mouse down and step away from the keyboard. It's great advice. But he specifically was talking about an example which was to parse a 12-hour time string and to basically see, is this valid? And what I've shown you on the screen is actually what it looked like after he did the initial refactoring. I would love to see the original version. The other thing to notice is there's a ... so there's a lot more where this came from. But what we're doing here is it's a very mechanistic, very imperative kind of like, we're approaching it. Absolutely nothing wrong with doing that. How you approach the problem, you approach it in the way that you feel you can at that moment. It's what you do next that matters most. Sometimes next is 5 minutes later, sometimes it's 5 days later. Who knows, it might even be 5 years later. But the idea is he's gone at this and gone like, well, yeah, I'm going to try and do this and do that and do that, and if I get an exception from that, then clearly it's not what I was expecting, so that's not a valid time string. And then he kind of goes away, chills, comes back the next day and goes, oh, wait a minute, this is a pattern matching problem. It's a declarative expression. And people are fond of saying things like, oh yeah, I had a problem, then I solved it with regular expressions, and now I've got 2 problems, which I think is, is a missed opportunity. They should be saying, I have star problems. But the other thing is, some problems just look like this. And the way that I think about this is, how would I explain this? How would I explain this to my kids, or how do I explain it to my wife, not a programmer? I would much rather read this out than this. Oh, okay. Reading from the left. Okay, what we're expecting is a group, and I'm expecting 0 followed by a 1 to 9, or I'm expecting 1 followed by 0 to 2. I can literally read this left to right, and somebody can follow it, and they don't have to know anything about programming. Good luck with this. Okay? The point there is, again, that's not immediately apparent. You get stuck in a way of thinking. That's natural because you have focus, and therefore you have this residual approach to solving problems. And if everything you see looks like a control flow problem, then that becomes the way you try and solve things. Sometimes refactoring is about not merely moving things around. It's actually a radical reinvention. So let's pick Dijkstra here. The purpose of abstracting is not to be vague, but to create a new semantic level in which one can be absolutely precise. We are looking for just the right way of expressing this. So this leads us to the home straight, where we need to consider, how are we going to do this? And an observation from Annie Dillard, the author Annie Dillard, how we spend our days is, of course, how we spend our lives. When we talk about refactoring is not something we save up for a rainy day, even though we cause the rain. Yeah, you see, I managed to work it in. We created that rain. Yeah, we create many of our own problems without realizing it. We don't get to see the whole picture. But the other thing is, sometimes we sort of, we'll save it for a refactoring sprint. And that refactoring sprint, strangely, never arrives. It's the same distance as the horizon, which is always the same distance away. It's like nuclear fusion. It's always 20 years away and has been since the 1950s. It's that, and we've got that refactoring sprint. Yes, we will do that in 3 sprints' time. It's always 3 sprints' time, or whatever is your local constant. But maybe we save it up. But also we say, oh, I'll do that on Friday, and then Thursday's work just didn't happen the way you expected. You got interrupted. You had other meetings. You had other things. Your kid was ill. Who knows? But here we are on Friday, and I'm doing what I was planning to do on Thursday. So no, I'm not refactoring today. And that's the point. That always happens. That's where it happens. And I've seen people come up with ambitious refactoring approaches and changes of philosophy, and then I say, okay, what are you going to do? Where do you expect to be in 12 months' time? Where do you expect to be in 6 months' time? 3 months? 1 month? Oh, 1 month, Kevlin. We can't because it's Christmas, it's summer holidays, and that is every single week of every single year. There is always something. So you've got to change the daily habits, which pushes us into a different way of understanding things. This tweet from Yvonne Lamb is one of my favorite ways of reframing this. A killer observation. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt. But we can't use it because tech has been made up of people who don't do housework or manage housework being done. She nailed it. Housework is the thing that is most similar to this, because in housework you are living in a home. The very act of living in a home makes it messy. That is not your goal, but just like the Maya Lehman quote, the very act of doing anything will make something else messy. The very act of being in the house. The very act of sleeping a night somewhere. The very act of going into the kitchen. If I go into the kitchen, I say, right, okay, I'm going into the kitchen. You know, my wife will say, what are you doing? I'm going to make a mess. No, I don't say that. I say, I'm going to make lunch. A side effect will be mess. My goal is I'm not going into the kitchen to make a mess. Honestly, I could do it in a lot less time. But there is a side effect. It is inevitable, no matter how good my habits are and practices are in the kitchen, I will make a mess as I'm going. I can minimize that, but I cannot eliminate it unless I put in additional work that involves putting certain things in a recycling bin, putting certain things in a dishwasher, getting things out of a dishwasher. I cannot just focus on I'm making a meal and it all works out. I have to account for extra work. Now, of course we knew this. For those of you who've been watching closely, this is the photograph I didn't take. This is Isabella Beeton. She was a figure in 19th century, mid-19th century England. She died at a tragically young age, actually. She was around 30. She was a contemporary of Charles Babbage and Ada Lovelace, but she would not likely have been known to them because her fame is that she wrote a book called The Book of Household Management. It turned out to be surprisingly influential, even into the 20th century, in terms of its recipes and how to run a house. And she gives us the advice that we need in the 21st century for dealing with our code. I love the way that 19th century software engineering is disguised as a guide to looking after your house. Very clever. There is no work like early work. Clear as you go. Muddle makes more muddle. Not to wash plates and dishes soon after using makes more work. This is how we want to approach our systems. It is always about the daily work. It's the idea that if we don't do anything, then the effort over time just accumulates. And I'm sure we are sick to death post-pandemic of exponential graphs, but here's an exponential graph. Because literally, unless you start tidying up as you go, then you are always having to deal with the problems of the past. And that's an interesting question. How much of what most developers do is fighting the past? The decisions of the past, the lost knowledge of the past. It's a surprising amount. In other words, oh, I'd like to do this, but I've got to move this out of the way, or I don't understand why that's... In other words, there's an accumulation. This is an accumulation curve. Well, we can schedule things in. That amortizes it in one way. And this has value. But we may find that if we make it normal, then we don't get to get rid of the curve. As our systems become more intrinsically complex through what they try to achieve, we should expect a rise in complexity. There's no perfection here, but we can certainly change our relationship to it and the relationship, the kind of social and the economic consequence. This is what we want to mean by maintenance, which, to go back to what I said earlier, maintenance is an action. What we are trying to deal with is the problem of inaction, the thing that we can't see, the thing that the dictionary quite cheerfully defines as neglect. Want of attention to what ought to be done, the fact of leaving something undone or unattended to. It's the thing that isn't done. And there's a lovely way, there's good language here that you can use from a business perspective. John Seddon, not a software guy, but a systems guy, made this observation and and given we're talking economics, how do we divide our work? What is the demand for my work? I am sitting here in front of a screen, and I am writing code. What is causing me to write that code? Or to spend time in front of the screen, because I might just be sitting there looking at this going, I have no idea what's... What is the demand? And he breaks it down into two. Of course, that we could find other categories, but let's just work with two here. Value demand. Value demand is the one everybody wants. What are you doing? I am adding a feature that the customer is going to use. Awesome. We would like, in an ideal universe, 100% of our demand to be value demand. Represents the demands the customers make for the things they want, things that are of value to them. That's great. But there's another one, don't you? It's called failure demand. Failure demand is demand caused by a failure to do something or do something right. Oh. And I have no numbers to back this up, but I do have anecdotes. And I remember noticing this. I didn't have the vocabulary at the time, but one particular client, just casual observation, I said to the department head, I reckon that in an 8-hour day, developers they are fighting the past for about at least 7 hours of that day. On a good day, there's 1 hour of value work that they're doing. On a bad day, it's somewhere between 0 and half an hour. In other words, that's the problem. The problem is the amount of work that is created by the past. There will always be work. By the way, you can never get the 100%. The idea is there will always be some amount of failure demand, but the question is, can we shift the balance so that most of what is happening is about value? So there is this observation that we want to kind of respect this. We need to, what is negligence? Not refactoring before a change. Not refactoring after a change. Not testing. Oh, yeah. You fear change at that point. Not reviewing code. Not recording decisions. We lose, much legacy is the lost decisions that we have. There's no perfect answer to any of these questions, by the way, or any of these challenges. There are just habits and ways that we can aim to improve where we stand. I'm not giving you an answer or any magic bullets. Not revisiting decisions. That's a biggie. That's a classic. Not updating technology, not using current versions. This is a huge one. Not turning down the build noise. Oh, we get warnings for everything. Oh, yeah. Not turning down the runtime noise. Yeah, the logs are useless. We just keep those to kind of use up disk space. We like paying for cloud storage. I don't know, whatever your reason is. We like looking busy. And there's many more. Notice these are not doing things. We are not saving time, it turns out, but that is a false economy. So, we'll bring this one to an end with, I've already quoted a couple of writers. When we think about software, we need to make a point to understand that it's in the nature of the thing that we are always working with incomplete knowledge. The knowledge you need for the thing you want to do today is in the future. But that doesn't mean you can't make progress. It just means that you need to have the opportunity to revisit. If you're a writer, you know this. You know that the first draft, there's a kind of a standard joke in writing, the first draft is for you, the second draft is for other people. But here we draft much more continuously. And that's the idea. It's okay to not get it perfectly right because that code is not going anywhere. We believe, we have a lot of product thinking. We don't just get rid of code after 2 weeks unless we made a mistake in committing it. The idea is that there's not software development and refactoring. There is refactoring as part of software development. It's woven in. And if we don't do it, that causes us the problems. Thank you very much.